So test is made up. I think there's 3 or 4 multiple choice questions. Key ideas, first of all, we have the notion of work. And in particular, we have 3 definitions, only one of which is on your formula sheet. What's the definition of work that's on your formula sheet? Work equals what? Force times distance. That only works, Grant, for a constant force. Put your phone away, kiddo. Thank you, sir. That only works for a constant force. What if it's not a constant force? Work is also the area under a force versus distance graph. That area there. Okay? Now, you don't know how to find the area of a curve. That was a phone that went off. Put it on vibrate. It's not the Tim Hortons rule right now because it's after school. You don't know how to find the area of a curve, but certainly I would have no problem giving you something like, let's make it a little more obvious, Mr. Dueck, something like this, and saying, hey, how much work was done in moving from point A to point B? Point A doesn't have to be 0. I could start partway along the way. It's still going to be the area. You'll either have a triangle, a rectangle, or a trapezoid, which really is a triangle plus a rectangle. Okay. The third definition of work was the work energy theorem, and it said, in fact, to me, it's the best definition of work. Work is actually the change in potential energy plus the change in kinetic energy. There is going to be at least one written question where I combine that with that. I ask you something about an object's potential or kinetic energy, but rather than give you any of the usual information, I give you a graph. Well, I told you it's potential or it's kinetic energy. It's the area underneath the graph. Then we had the law of conservation of energy, and again, thunder should roll, lightning should flash. Very, very important. But again, Logan, not on your formula sheet. One of the few things that'll really irritate me is if kids haven't memorized this. As much as I hate memorizing, there's some stuff you do have to memorize. Kids that haven't memorized this, it says to me, you know what, they didn't do the homework. It's initial plus initial equals final plus final. It's the amount before equals the amount after. As an equation, it's or if they're talking about friction, fair enough, plus heat. But that's optional. If we're in a frictionless magic physics world, we can ignore heat. It's also a scalar. Please remember that potential energy, is stored energy. Usually it's mgh, but this could also be the area underneath the graph. That's stored energy. This could be the force times distance of a bow and arrow. That's stored energy. It's not mgh, it's force times distance. It could be the force times distance of my gun. Force times distance. That's stored energy. And in fact here, what's the stored energy get turned into? Okay, kinetic. What did I hit? The screen or the whiteboard? Okay. So putting everything together is important. When do I, when do I absolutely want to use the law of conservation of energy? Use when what? There is a change in height, change in speed, and especially when there is a yucky, curvy, okay, path. Roller coasters, ski hills. You can also use it when there's like a straight inclined ramp, like from last unit. That works as well. We did several questions in the homework where we showed, because conservation of energy is a scalar, we found the work done just by going vertically. But we also found it by going along the ramp. It's doable. But roller coasters, ski hills, questions like that. And then the last thing that we looked at, power. We said that power was work over time. That one's on your formula sheet. The one that's not on your formula sheet was us getting clever and saying, since work is force times distance, and it's still over time, what was distance over time if we were clever enough to spot it? Meters per second, it's velocity. So really, it's also force times velocity. We'll use our punchline. Power is measured in what? In watts. Okay. And we can do a lot there. There will be a question also about efficiency. Efficiency. Recall, it's always smaller number divided by bigger number. It can't be more than 100% efficient. But Emma, make sure the units match. Make sure you're dividing watts by watts or joules by joules. Don't divide watts by joules. It means, oh, if they gave me one of them in watts, probably I can convert the other one to watts with a bit of cleverness, or convert the watts to joules. Or I can make the units match. So, questions that I like from the review here. I'll tell you in more detail, but specifically about the written section. I'm looking for. Oh, that's the answer key. How about I go to the blank one, Dueck? Certainly something like number 10. I said if I wanted to give you some kind of a question that in combined force, distance graphs, and the work energy theorem, in fact, it would go something like this. Suppose 5.6 kilogram object experiences a changing force as shown below. Clip. Yoink. Okay, there's a force versus distance graph. Assuming we start from rest, how fast is the object traveling after 6.0 meters? Let me make this a bit smaller so I can get this all into one screen. There we go. Suppose a 5.6 kilogram object experiences a changing force as shown below. How do I know the force is changing? It looks like the force is getting bigger, so I can't go force times distance. Assuming we start from rest, how fast is the object traveling after 6 meters? What does this question want me to find? What does this question want me to find? V final. What have they given me? Well, I don't know that there's a yucky, curvy path. I don't know if I'd start going conservation of energy. They've given me a force versus distance graph. So I think what I would do is I would start, Darian, with this. Work equals the area underneath this graph. Oh, but work also equals the change in potential plus the change in kinetic. Well, if those both equal work, then Anthony, they equal each other. This is what I can do. I can say, okay, the area is going to be, and you know what? I think we'll cross out the change in potential. I don't think that there's a change in height mentioned here. It's going to be the change in kinetic. Noah, what's change in anything? So this is going to be kinetic energy final plus, Mr. Dueck? Noah said minus, good gosh, minus kinetic energy initial. Now, in conservation of energy, it's plus. In change in, it's minus. Noah, how come I can do that? from rest. Oh, traveling after 6 meters. Now, after 6 meters, that's going to be this section. Although they gave me all the way to 8 meters. For some reason, they just asked up to 6 meters. Okay. What is that area? What shape is that? Triangle. Area of a triangle, which actually is on your yellow formula sheet, by the way, is base 6 times height 12 divided by 2. 6 times 12 is 72 divided by 2, 36. And I get this. 36 equals 0.5 m v final squared. I guess v final is going to be, well, you know what? Instead of 0.5, why don't I put a 1/2 there? Because then I can go times by 2, divide by the mass, which was 5.6 square root. So, question? No. There's an example, Rachel, of a question that combines 2 different versions of work. I like that question. I like that question. I like that question. But what I love, sorry, what? I didn't finish it. Do you want me to? Okay, the mass is 5.6. So let's put a 5.6 down here. So it's going to be 2 times 36 divided by 5.6. Square root of that. It's going to be traveling 3.6 meters per second. Happy now? Good, shut up. Roller coasters. Roller coasters, roller coasters, roller coasters. Let me find a good picture of a roller coaster that I... Ooh. Done ones like that. I'm looking for something else. Let me just think here. I'm looking for... okay. Keep going, Mr. Dueck. What do we got? What do we got? What do we got? Sure. So, roller coasters, water slides, ski hills, etc. I'm looking for a specific diagram. What I was looking for was a diagram that didn't have a height in it. So, suppose right here at the top, V initial was 5.2 meters per second. And suppose at the bottom, V final is faster, obviously. What do you think? 8.9? Let's make it a little faster than that. 12.1 meters per second. And suppose we also knew, so given those numbers, if 2,500 joules of heat was generated, how high is the slide? We've done a bunch where we found V, usually a V squared square root. So for twists, how high is the slide? I think I can make this a bit bigger and fit most of it on the screen. Sure. How would we handle this? What's this question asking me to find, Ryan? Height. Any suggestions on how? Is there a curvy path? Is there a change in height? Is there a change in speed? Any thoughts? Conservation of energy. Do you want me to include heat? Okay. So I have this. Kinetic initial, potential initial, kinetic final, plus potential final, plus heat. Are any of these 0? PEF? KEI? No, we didn't start at rest. It'd be nice, but no. Okay. It's going to end up being a half mv initial squared plus mg H initial equals a half mv final squared plus heat. Ryan, what did you say they're asking us to find, Rye? Which one? Oh, there's only one right now, so I guess I want to get this by itself. How? How will I move that over? Yeah, let's not get fancy. I mean, I could maybe divide by 2 and junk, but I think this is going to be ugly no matter what. So rather than look for shortcuts, let's subtract. Okay, so that'll move that over. Then what? Yep. So I'm going to get this. Here we go. Height initial equals 0.5 mv final squared plus the heat, subtract 0.5 mv initial squared, all divided by mg. Mr. Dueck, I got m's here and I got an m here. The m's cancel, don't they? No. Why not? Oh, I don't have an m and e. Now, if I'd made this frictionless, sure. It'd make it a little easier, to be quite honest, but that's okay. I want it to be a bit more realistic. I think now we're plug and chug. Let's see. It's going to be 0.5. Did I give a mass? I did not. How about m equals 74 kilograms? I would make sure I did that on the test. Whoops. So 0.5 times 74 times, what did I say V final was? 12.1 squared. Plus, how much heat did I say? 2,500. Minus 0.5 times 74 times, what was my initial speed? 5.2 squared? All over 74 times 9.8. So this would be a nice question. Let me shrink this down so I can get most of this on one page. Am I close? Almost there. And we get my initial height is 0.5 times 74 times 12.1 squared plus 2,500 minus 0.5 times 74 times 5.2 squared divided by 74 times 9.8. This could be a terrible answer. Let's see. Oh, okay. 9.64 meters. That's not that bad. Is that right? Anybody else try it with me? Okay. Shaq, you did? I'm right? Or are you just nodding to try and look intelligent? Uh-huh. Little column A, little column B. In other words, as far as I'm concerned, Logan, in the conservation of energy equation, I can ask you to find any one of these. Height initial, height final, V initial, V final, heat. Heck, I could even, I guess, technically ask you to find the mass, although I probably wouldn't bother. There's going to be a couple of those on the written. Okay. You done and caught up? Yeah. Okay, can you hand them in back there? I'll mark them tonight. If you're fibbing to me, I'll expect to see you tomorrow after school. Thank you, sir. There's going to be on the written a couple of those, I think. In fact, I think I've given you a pretty good indication of what you might see on the written section. Multiple choice. Let me first of all tell you which questions from the review that I like, and then I'll take any questions you want me to go over. There's probably going to be one or two conceptual ones. So certainly I like number 2. I doubt I'm going to throw something as easy as number 3 at you. That's like free marks, but okay. I like number 4. You know what? Because you guys probably want this in the tutorial, let me do this. Questions from the review that I like, colon. And let me pause the video for a second and get a copy of the review. Questions from the review that I like. Certainly I like number 2. 4 is good. 5 is good. That combines a little bit of everything. 7 is good. I like number 7. I like number 7. I like number 7. Number 8 is good. 9 is good, using an area to solve for something. Oh, number 9, interestingly, is asking you to find a mass. A little trick here, but you can get it from there. I like number 10. I like number 10. Sure, 11 is good. 12, but to be honest, number 12 says how much work was done in moving the object from 20 meters to 60 meters. I'd probably ask you to do something with that answer. Now you know how much work, that's probably how much energy the object gained. Certainly, I like number 13. I like number 13. I like number 13. I like 15, because there's a graph there too. $20, 22. 22 has a nice little mini curveball. Part B asks for the average force of friction acting on the cart. See if you can think about that one. 26. $28. Oh, I said type 36. I said 26 because I'm typing in a hurry. How about 26? Thank you. 28. 33. 34 is a little nastier because in 34 they don't give you the speed at the bottom of the slide. What they give you is the range that the person traveled in 0.45 seconds and how long they fell. So 34 is a little tougher than I'm going to ask, but the concept of a water slide that's a nice application of the law of conservation of energy, G. 35. 38, anybody have the review in front of them? 38, I would solve using forces, not energies. In fact, 38, I gave you on your last test. 38 is a ramp. There's a block moving up the ramp with an initial speed of 11 meters per second, and it's saying how far up the ramp will it reach. I gave you that question on your forces test, as a matter of fact. And also, it's at an angle, and I've told you I'm not going to give you... You can do those, please. They're good practice, but I'm not going to give you component questions on this test. Same with 39, by the way, as a component question. I'm not going to do that. 41's a little overkill. Yeah, you know what? There's the questions that I like. So, I mean, this was fairly short because there hasn't been all that much to this unit. But having said all that, questions from the review or from the homework that you would like me to go over, now is your chance to ask. Grant has a question? Excellent. Thrilling. Can you put that, make sure your name's on it back there? Can I do what? 18? Maybe. First of all, I'm going to show you, have you looked at my online answer key, Grant?
I did not.
Okay, stop. I'll do that for you because I care.
Okay.
Despite the fact that you're showing up late today. By the way, 18 is pretty nasty. So this one, a lot of kids can't figure out from my answer key. You ready? This gives you an idea of what kind of a nasty curveball. In fact, the provincial exam that I took this one from was the nastiest. That this question was done the poorest. I had the results. I think something like 85% of the kids got this one wrong. You ready? Well, it says this object starts from rest and it slides down a frictionless track as shown. I said, well, I got a curvy path, I got a change in height, I got a change in speed. I'm probably going to use conservation of energy. It leaves the track horizontally, striking the ground. And I put a little X here. I said, you know what? That there is dx. a range. Now I'm actually already thinking projectiles and horizontal and vertical and T-chart and all that. Twice the height, how far away will it land? So here's what I said, Grant. Just watch, don't write. I know that horizontal distance is horizontal velocity times time. I said, from the same height, time will be constant. No matter how fast it's traveling sideways, its vertical drop height is going to be the same, so its vertical time is going to be the same. I said, what happens to Vx? Well, an expression for V right here would be, I got the V by itself. I said, there's an expression, I guess the speed, which ends up being the horizontal velocity, is 2 times g times h square root. You okay with that argument so far? Okay. So I wrote, this is Vf. What if I double the height? If I double the height, that's really putting a 2 right in front of the h. Like that. Which really gives me the same thing I had before, a 2, a g, see it? And an h, but there's an extra root 2 kicking around. Is that okay? Because I doubled the height. That 2, that red 2, I said, you know what? If I put it in front, that gives me my original Vf. In fact, I said, it looks like if I double the height, I don't get twice the speed. I get root 2 times the speed. With me so far on that argument? So doubling the height increases Vf by a factor of root 2, which is going to increase my distance by a factor of root 2, not by 2. Now that's an algebraic argument. My little math nerd heart's going pitter-pat. In fact, those of you that are here, I almost guarantee that when I do my 10-minute tutorial at the beginning of the energy test, someone's going to ask me to do this question. I may pass because it takes a while to explain, and this is tougher than you're going to see on your test. But you could also make up numbers. You could say, hey, let's suppose the distance was 10 meters. If you knew the distance was 10 meters and you made the height of this slide, 3 meters, you could solve for time, you could solve for V, you could figure out how high you actually had to start out, double it, and you could crunch the numbers and see what kind of a pattern you got. That's a lot of work. Is that okay? No, there is one nasty multiple choice. It will be the toughest multiple choice you get all year. Don't freak. I'll give you some hints about it. Pardon me? No, better than that, because your other option is to actually reverse engineer all 4 answers. If you save it for last, you'll have time to do that. Is that another hand up, Grant? Any other questions that you would like me to go over from the review? Yeah.
Yeah, I tried to do 10, but I couldn't get the right answer.
You looked at my online answer key showing all my steps? Boy. Okay. So you went, you got an area of 64 joules? No? Because it's base times height divided by 2? Or not?
I got it.
Oh, okay. Right? I said it's this, and that's going to be the change in kinetic energy, because it does say a horizontal surface, so what's my change in potential? Nothing. So its kinetic energy is 64 joules, and if you knew its mass, you could now find out how fast it was traveling if it started initially at rest. Did it tell me the mass? Oh, they did. So another part, same question would be, instead of saying how much kinetic energy, how fast is it going? Is that okay? Any others? Zach, no? That's not a hand up?
No, he's explaining.
Trampoline question? 17?
No.
Oh, okay. Yeah.
Can you just go over 34?
Yeah. Did you look at my online? You know what? I don't even want to ask. Oh, sure. Starting from rest, I'll give you a 0. Convenient. I said clearly this is a yucky curvy path change in height. This is clearly a conservation of energy. Now, it says the person traveled 6 meters. And the height of the slide is, the time was 0.45. I said, okay, you know what? They gave me dx. There's a good sneeze. Dx is, remember from Unit 1, vxt. Did they give me time? Did they give me the distance?
Yeah.
You know what the horizontal speed at the bottom must be? 13.33. That's my v final. And because it's a scalar, although it's horizontal at the bottom, I don't care. That's my speed. That's my kinetic energy, half m, that v squared. So then I said, okay, hey, we're starting at rest. And I said, now I'm going to treat the slide as though it's ground level. I ended up with mgh initial equals a half mv final squared. No friction, so mass is canceled. How would I get the h by itself? Divide by g. And instead of having a 1/2, I just put a 2 on the bottom. Which v? That one there. Okay. 9.1 meters. Now, suppose we did the same height but a much steeper angle. Why is it going to be exactly the same distance that I slide? I'm looking for one word that begins with an S. Okay. So if dx is vxt, it's going to be the same time of flight because that's your vertical drop. What will your speed be from the same height, even if it's steeper? The same. Why? Because work and energy are what? Scalars. You guys done? Okay, handed everything in? I'll be checking my list and making it twice. Scare them with that. Scalars. Okay? Yeah, they're grade 10s. Okay? So, the path is irrelevant. Energy is a scalar. In fact, even if we were doing this before getting to the ground, I don't care. It's still going to be the same speed at the bottom. It's a scalar. What if, in this case, what if it was someone fatter? Would that make a difference? The effects of friction on air resistance are negligible. So, in fact, there it is. The m's canceled. Wouldn't matter if it was a, tiny person or a bigger person. Okay. Any other questions from the homework, from the review, from anything you want me to go over? We good? I don't know. There's not, Jake, much to this test as far as I'm concerned. I don't know. I don't want to oversimplify it. Yeah? It's worth 6% overall. They're usually in the 40s. When the provincial was set up, they deliberately set it up so that each mark took about a minute. In fact, it was a 120 mark test for 2 hours. It was 120 minutes long. And you could almost budget it that way. I heard that. You could almost budget. So most of my tests are going to be out of around 45 or 50 because classes used to be an hour and we went to 80-minute classes. I didn't want to lengthen the tests. I added the 10-minute tutorial in front of each test instead, since you asked. I'm going to pause or stop, but I'll check. Anyone else still? Going once? Okay, let me pause the video.